Good morning, this is your stats sensei, Mr. Spensei, and we're looking at 2018 question number 4. So the anterior cruciate ligament, ACL, is one of the ligaments that help stabilize a knee. Surgery is often recommended if the ACL is completely torn, and recovery time from the surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of the new procedure, a study was conducted in which 200 patients needing surgery to repair a torn ACL were randomly assigned, that's really important, to receive either the standard procedure or the new procedure. Based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? So we're looking for a reduced recovery time, which means the new one would be faster than the old one. All right, so, and what they want to know is if it were statistically significant, could we make a conclusion? Well, in order to make a conclusion, we have to have causation, which means we have to have an experiment. Yes, if the test is statistically significant and shows a faster recovery time for the new procedure, it would be appropriate to conclude that the new procedure reduces recovery time because the study is an experiment and treatments were randomly assigned. All right, so we have to have the correct decision. We have to back it up in context, and we have to say treatments were randomly assigned. If you don't have randomly assigned, if you're missing one of those words, you're going to a partial. You have to say random assignment, randomly assigned. And make sure it's not sample, it's assigned. Super important there. All right. Moving on to the next part. Do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for the patients in the study? So they want to know whether or not they have convincing evidence, and they didn't tell me how I could go about this, but I'm going to run a 2-sample t-test for means. Important to name the test. So let mu1 equal the true population mean. And by the way, for the standard care, and I could have used mu-s, all right, let mu2 equal the true population mean recovery time for the new procedure in days, and I could have put mu-new. And we're saying the mean of the standard time takes longer than the mean of the new procedure. So mean of the standard takes longer than mean of the new. Real important that we have all that information. Our conditions, random assignment, it was given for both samples. Make sure you include the word both. Make sure you're using the word assignment. Independent populations, reasonable to assume the surgery recovery time for one group will not impact the other. If you did not have that, not a big deal. The n is less than 10% was not necessary. All right, if you have it, it's not counted against you. Our sample sizes are 100 and 110. Both are greater than 30. So the distribution of the sample means are approximately normal by central limit theorem. Important to have that condition. So we write our formula down. Once we've written it down, we cross it out because we don't want it graded, and we plug in our numbers. Well, our mean for the standard was 217. The mean for the new was 186. There's our standard deviations and our sample sizes. So, stat, test, 2-sample t-test, X bar 1, recovery time of 217. Standard deviation of 34, and the sample size of 110. This is the new mean, which is 186. And the new recovery, 29 standard deviation, and a sample size of 100. And then we need to make sure that we match our how we set up our alternative hypothesis. I have mine set up as a greater than, where the standard was greater than the new. Depending on how you definition it. We don't pool. And I get a t-statistic of 7.127 and a p-value Notice is greater than 1, so I must have an exponential. So it's 0.0 with 11 zeros. So it's essentially 8. All right, so our T statistic, 7.127. You had to have this written down. That probability is essentially 0. We also need to include the degrees of freedom. And I didn't calculate those by hand. The calculator did that for me. All right. So our p-value is approximately 0, and that's less than alpha of 0.05. We must have the comparison. You can use a less than sign if you want. And then we need our decision, reject the null. Then we put it into context. Our p-value is approximately 0, which is less than alpha. We reject the null. There is sufficient evidence at alpha equal 0.05 to suggest the true population difference for mean recovery time is greater for the standard procedure than for the new procedure. The new procedure appears to have shortened recovery time, or that the true population mean recovery time is greater for the standard procedure. Probably better to phrase it like that. True population mean recovery time is greater for the standard procedure than the new procedure. The new procedure appears to have shortened recovery time. All right, so when we go about scoring this thing, let's go back all the way up to the very top. And in the top, I've already discussed that you had to have random assignment, you had to have the correct decision, and you had to put it in context. For this part, for the actual running of the test, we had to have parameters defined correctly, a correct null and alternative hypothesis, and a correct T statistic. And we also had to include the normality condition. They weren't concerned about this because they addressed that up above. Normally, this is also required. If you had all those components, you received an E. Otherwise, you received a partial. All right, the next section, section 3, made the comparison. All right, made the comparison and the correct decision. And then you wrote it up in context, referencing the alternative hypothesis with the main. And so with that said, if you have that all of that information, that will get you an E. If you have 3 of those, if you have 2 of those, then you only get a partial. All right, I hope that helps, and we'll see you on the next one.